Magis Day students, welcome to another day of learning. In this video, you will learn to illustrate situations involving direct and inverse variations and also solve problems involving these types of variation. Alright, here's a real life application of one of the types of variation. Using his bicycle, Jesse travels a distance of 10 kilometers per hour on a steep road. The table below shows the distance he has traveled at a particular length of time. Now, based from this situation class, what do you think is the type of variation involved? You're right, it's actually direct variation. Now, I want you to look at the table, all right? And notice that as the time increases, the distance traveled by Jesse also increases. Now, would you agree with me, class, if I'd say that there's actually a pattern in generating the data on this table? And using this pattern, I'd like you to calculate how many kilometers would Jesse have traveled in 8.5 hours. So basically, we just have to multiply the 8.5 with 10, since 10 kilometers is good for 1 hour. And that will lead us to a conclusion that for 8.5 hours, Jesse have traveled 85 kilometers. But what if there is no table given, class? How will you still find Jesse's distance? Now, this is where you'll realize the significance of formulas, equations, or mathematical statements. This problem actually tells us that distance traveled by Jesse is 10 times the length of time. So it's basically D equals 10 times T, with 10 as the K or the constant of variation. Now, let's dive into the first type of variation, which is the direct variation, where an increase in x is also an increase in y, and an increase in y is also an increase in x. Now, you might be wondering what are possible key concepts or good indicators that a problem involves direct variation, aside from the fact that as x increases, y also increases and vice versa. So we have here the commonly used statements. So we have y varies directly as x, y is directly proportional to x, and y is proportional to x. All of these equates to y equal k times x, where k is the constant of variation. Okay, now before we solve problems involving variations, it is extremely important, class, that you know how to write equations of variations given a certain description of the situation. I have here examples for direct variation, but please bear in mind the formula of this type of variation. And what is that again? It's y equals k times x. So for number 1, we have m varies directly as n. Now take note, class, the first thing that we need to do is to identify what variables are being used in the statement. So we have m and n. And since it says here varies directly, so of course it's direct variation. And we just have to refer to the formula. So the equation will be m equals k times n. Alright, do you get it? M equals k times n, with k as the constant of variation. Now let's proceed with number 2. The area of a circle is directly proportional as the square of the radius r. So once again, we have to identify what variables are being used in this statement. So we have capital letter A and the small letter r. All right, so when we write the equation, it will look like A equals K times R squared. Why R squared? Because it says here square of the radius R. All right. Now let's move on to solving problems involving direct variation. I have here my first example. If y varies directly as x and y is 15 when x is equal to 3, find y when x is equal to 5. Now, again, the first thing that we need to do is to identify what variables are being used in this problem. Okay, so we have y and x. And after that, we have to solve for k, since if we're going to analyze the problem, the constant of variation is not given. But on the second clause, we have here y is 15 when x is equal to 3. And these are the values that we're going to substitute to the um, equation. So we have y equals k times x, and for y we have 15, and for x we have 3. By the way, class, k times x can be written as x times k. So that's commutative since it's a multiplication. Since it's multiplication. Okay, so after this, what do? We divide both sides by 3 so that we can get k. And dividing both sides by 3, we get k is equal to 3. So now that we have k, we can solve for y, because it says here in the last clause, find y when x is equal to 5. So now that we have k, we solve for y again. We solve for y, and then how do we do that? We write the equation again, y equals k times x, and we substitute 5 to x and 3 to k. So we have there y is equal to 3 times 5, and that will give us y equals 15. So for this problem, y is equal to 15. Okay, now let's proceed to the second example. If y varies directly as x and y is 35 when x is 1/2, find x when y is equal to 5. So again, class, the first thing that you need to do is to identify what variables are used in the problem. Now in this case, we have y and x again, and after doing that, we have to solve for k, since k is not given in the problem. So we rewrite the equation. We have y equals k times x, and we substitute the values given in the second clause. So we have y is 35 and x is equal to 1/2. Okay, so from here, remember that we have to divide both sides by 1/2. So 35 divided by 1/2, or you can also multiply both sides of the equation with 2. So 35 times 2, that will give us 70 for k. Now that we have k, we can now proceed with solving what is really asked in this problem, and that is x. Okay, so we have to use the value for y in the last clause, and of course the value of k that we just solved. So again, we write the equation y equals k times x, and we substitute the values. So for y we have 5, and for k we have 70. Alright, and since we're solving for x, we have to divide both sides of the equation with 70. There you go. And after that, we can conclude that our x is equal to 1 over 14. Okay. Now let's try solving word problems involving direct variation. So I have here the amount of paint P needed to paint the walls of a room varies directly as the area A of the wall. If 2 gallons of paint is needed to paint a 40 square meter wall, how many gallons of paint are needed to paint a wall with an area of 100 square meters? So basically in this problem, the variables being used are P and A. Okay, so from there, we have to write the equation. So that's the first, that's the second thing that we need to do after identifying the variables used. So the equation is P equals K times A, since it says the paint needed to paint the walls of a room varies directly as the area A of the wall. So P is equal to K times A. Um, and in this case, again, K is the constant of variation. So after that, still the same process. So we solve for K and we write the equation again, and we substitute the given, which is found in the second in the last no in the first clause of the last sentence. So we have 2 gallons of paint and then 40 square meter wall. So P is equal to 2 and then A is equal to 40. And from there, we divide both sides of the equation with 40 to solve for K. So K is equal to 1 half. So why 1 half? Because we have to simplify. 2 divided by 40, that's 1 over 20. Sorry, not 1 half. 1 over 20. Now that we have K, we can now solve for what is being asked in the problem, and that's the number of gallons of paint. So solving for P, again we write the formula or the equation and we substitute the values that we have. So K is equal to 1 over 20, and the area of the room, I mean the wall, is 100. So we have P is equal to 1 over 20 times 100. And what do you do? What do you do after that? You multiply 100 with 1. Okay, and that's 100. You divide it with 20, so P is equal to 5 gallons of paint. You can actually just do the cross multiplication, not cross multiplication, but 100 divided by 20. That's it. So you get 5. All right. Here's another problem involving direct variation. The number of kilograms of water W in a body of a person varies directly as the mass m of the person. If a person with a mass of 990 kilograms contains 60 kilograms of water in his body, how many kilograms of water are in person with a mass of 130 kilograms? And again, no, we have to identify what variables are used in the problem. So we have W for water, no, number of kilograms of water, and M as the mass of the person. And from there, we write the equation. W is equal to K times M. I repeat, W is equal to K times M. Since it says there, W in a body of a person varies directly as the mass of the person, with K again as the constant of variation. Now that we have the equation, class, we can now proceed with solving for K. So we write the equation again, and then we substitute the 990 to the mass, and then the 60 kilograms for W. Dividing both sides with 990, so we get K equals 2 over 33. How is it possible? Of course, we have to simplify 60 divided by 990. So you'll get 2 over 33. Now that we have K, class, we proceed with solving for what variable? Solving for W. Okay, the number of kilograms of water. So we write the equation again and we substitute 130 for M and 2 over 33 for K. So we have there 2 over 33 times 130. If you do the math, you have W is equal to 7.88 kilograms. Now, what have you noticed, class? What have you noticed? If a person with a mass 990, and then if you're going to compare the 990 with the second mass, which is 130, what did you notice? Diba? It's decreasing. Okay, it's decreasing. And for 60 kilograms, which is the first that's actually first number of kilograms of water. So 60, and now you have 7.88. What have you noticed? It's also decreasing. Okay, so this is what I was telling you a while ago. While the x increases, the y also increases. Or if the y increases, the x also increases. Okay. Now let's have inverse variation. For two quantities x and y, an increase in x causes a decrease in y, or vice versa. This time, it's the opposite of the direct variation. Because imagine, an increase in x causes a decrease in y. And an increase in y causes a decrease in x. Okay, let's have examples. Oh wait, before that, we have here the commonly used statements for inverse variation. Okay, so this will be your indicators, no, that a problem is involving inverse variation. So we have y varies inversely as x, and y is inversely proportional to x. And these two statements actually equates to this formula here, no? Y equals k over x, where k again is the constant of variation. So now, let's try writing equations of inverse variation. So for number one, we have Boyle's law states that at a constant temperature K, so this time the K is already stated, it's already given. The pressure P of an ideal gas is inversely proportional to its volume V. Okay, so it's inversely proportional. So what are the variables used? We have P and then we have V. Okay, so how do we write the equation? Remember the formula for inverse variation? That's y equals k over x. Now in this case, for number one, so we're going to write it as P equals K over V. Do you get it? Okay. Now let's proceed with number two. The number of persons N needed to do a job varies inversely as the number of days D to finish the job. This is actually true to life, no? Okay, so you identify the variables used in this statement. So we have N and D. And how do we write the equation? We have N is equal to K over D, with K again as the constant of variation. Now let's have here a problem involving inverse variation. So we have if Z is inversely proportional to V, and V is equal to 2 when Z is equal to 1, find Z when V is equal to 9. I know what you're thinking, class, no? This might sound confusing because there are a lot of values that you need to consider. But actually the bottom line of this lesson is just to familiarize the formulas for each type of variation and to know how to manipulate, how to deal with these formulas or equations. So for this problem, again, it's the same step with direct variation. We just have to solve for k since k here is not given. Okay, so identify what variables are given. First, we have z and v. And from there, we can write the equation, which is z is equal to k over V. All right, so now we use the values in the second clause. We have V equals 2 and then Z equals 1. So we substitute it to the formula, to the equation there. And if solving for K, we cross multiply 1, no? So 1 times 2, we get K is equal to 2. All right. Now that we have K class, we can solve for Z already. And Z here is actually what's being asked in this problem. So we have to write the equation once again. Z equals K over V, and then we substitute this one. We substitute 9. Okay, I mean 9 for V and then K for 2. So that's how it will look like. Z equals 2 over 9 because our K is 2 and our V is 9. And we're solving for Z. So since you cannot simplify further 2 over 9, then our final answer for Z is 2 over 9. Okay, sounds easy, right? Now let's try to integrate inverse, the concept of inverse variation in a real life scenario. So we have here the number of days D needed in repairing a house varies inversely as the number of men M working. It takes 15 days for 2 men to repair the house. How many men are needed to complete the job in 6 days? Okay, take note. So we have here 15 days. That's the first given for D, no? 15 days. And then the second given for D is now 6. So what have you noticed? It's decreasing, no? It's decreasing. And one thing to confirm that our answer is correct is to do it like this. If D is decreasing, we have to make sure that our final answer for M um will make it increasing. So first we have here 2 men. Our answer for M must be greater than 2, of course. So again, the first step is to identify what variables are used. So we have D and M. And from there, we write the equation. So the equation is D equals K over M. All right. And after writing the equation, we can now proceed with solving for K. So we write the equation once again and we substitute the values 15 days and then 2 men. So D equals 15, K over 2. So we cross multiply class 15 times 2. Our K will then be equal to 30. Now that we have 30, we can now proceed with solving for what is really asked in the problem, and that's the number of men needed to complete the job in 6 days. So solving for M, we write the equation once again, D equals K over M, and then we substitute for D we have 6 and for K we have 30. Okay, and then we do cross multiplication. 6 times M is 6M. All right, and then we have on the left side we have 30. So 6M equals 30. We divide both sides by 6 there, and from here we can say that M is equal to 5. So in conclusion, do not forget to always end your answer, no, your solution with a conclusion. So in conclusion, we can say that 5 men are needed to complete the job in 6 days. So as you can see, from 2 men, now it becomes 5 men. So it's increasing. And then the number of days are decreasing. So from here we can verify that we're doing the same, I mean, we're doing the correct solution. Okay. Now let's have another problem involving inverse variation. The current I in amperes is inversely proportional to the resistance R in ohms. If the current is 30 amperes when the resistance is 3 ohms, what is the current when the resistance is 5 ohms? Again, the first thing that you need to do is to identify what variables are used in this problem. So we have I and R. And from there, you write the equation, you derive the equation. It's I equals K over R. Okay, with I as the current and R as the resistance. And after deriving the equation, we now proceed with solving for K. We write the equation once again and we substitute the values. For I, we have 30 and for R, we have 3. So then from here, we cross multiply 30 times 3. So that will give us 90 for K. Now that we have 90, we proceed with solving for I. I is actually what's being asked in this problem, current, no? So we write the equation once again, and then we substitute 5 for resistance and 90 for K. And from here, we cross multiply I times 5, that is 5I equals 90. So you put 90 on the left side of the equation. And what to do next? We have to divide both sides of the equation with 5 since we're trying to solve for I here. There you go. And then 90 divided by 5, that's actually 18. So in conclusion, 18 amperes, uh, the current is 18 amperes is the current when the resistance is 5 ohms. So there you go. That ends my discussion on direct and inverse variation. I hope by now you can write equations and solve problems involving these first two types of variations already. And if this video class was helpful, kindly give it a like and share it with your friends or relatives who might have the same lesson as yours. Also, please don't forget to show support by subscribing to my channel. Thank you so much everyone and see you in my next video for more math related tutorials.